So hello, now in this video we will do these two important diagrams. We will see these two important diagrams. Okay, so till now we have seen Boolean algebra, okay, and various properties, etc. But now we will see this diagram. So this diagram is very popularly known as L1 star and L2 star. Okay, so now we will see this distributive property on lattice. Okay, so now here we have I think you remember this is LUB and this is GLB. Okay, LUB means least upper bound, GLB means greatest lower bound. Okay, so now we will try to find out that if this distributive property holds for this L1 star diagram. Okay, so now let's see. So now let's take another color. So now here A or sorry, this is or you can say, or you can write it as LUB B GLB C. Okay, so B and C, greatest lower bound of B and C. So B is here, C is here, greatest lower bound here is X. Okay, so A LUB X. So A LUB X means A lower bound lowest upper bound of X. Okay, so A lowest upper bound of A is here, X is here, so LUB of both this is A. So now let's say this is a question mark, so just not put equals to here. Let's try to find out if this property holds. Okay, so now let's see here A LUB B. So A LUB B means A is here, B is here, so A LUB B means lowest upper bound of A and B. So here they are meeting at Y, so this is Y, this is GLB. Let's do this in next step, don't just put here. Let's find out this A LUB C. A and C is here, they are Y, LUB is Y, so Y GLB Y is Y. So you can see this is A not equals to Y, so this distributive property doesn't hold. Distributive property doesn't hold. Okay, so this is very important. So please write this diagram in your notes and somewhere so that you can remember. So this is very important, I'll say, because why this is important, you can just find out if this is a submatrix sublattice of some lattice. So this is very important. So yes, I'm trying to tell you to remember this because this will help when you are solving a big question. If you find this as a part of that question, you can just write down directly that this lattice is not distributive. Okay, so I'll give you some time to write it down. I will do this L2 star now. Now let's see L2 star. I hope you have made this note somewhere. Now let's see L2 star. So same thing, we have to prove if this is equal. So if this distributive law holds. So I will say check LHS and RHS. If it is true, then we will say that distributive law holds here, or else we will say this is false. So now let's find out. So first write it as A. So now B GLB C. So B and G are sorry, not B and G, sorry, B and C. So B is here, C is here. Okay, so GLB means greatest lower bound. B and C are meeting at X. Okay, so now A or X. So A LUB X. A lower bound, lowest upper bound, sorry, not lower bound, lowest upper bound. So A is here, X is here, so the lowest upper bound is A, the highest one, so A. Okay, so now let's see here. So A or B. So A and B is here, lowest upper bound. So X and A, B and A. So this B is the lowest upper bound. Now this GLB and put A or C. A and C join this LUB, lowest upper bound is Y. A and C is here, lowest upper bound is Y. So now B and Y, this is meeting at B is here, Y is here, greatest lower bound is B. Okay, so now you can see A is not equals to B. Again same thing, distributive property does not hold here. Okay, so please try to remember this L1 star and L2 star. So I'll move somewhere else so that you can see. So please try to remember this, that these two diagrams. See, I've already given you the proof how it is done, so you can also prove it by yourself. But the thing is, if a big lattice is given, as I've already told you, so it's better to, if you can find out that this is a sublattice of this is present in the bigger lattice, so you can just write away directly this is present, or some question may be asked like this. So I will do some questions on this. So just hold on, we are almost at the end of this concepts. So we will do the concepts in now, and then we will move on to questions. Okay, so another thing, an important thing, let me write it down here. So another property is, let me write it down in red color. So here dn, this divide, is always distributive. Okay, so we have done some question on this. N is number of divisors, positive divisors here in dn, and this is the relation, here it is divisor. So this is always distributive. Okay, so some question may be asked, so we will see some properties more, but try to remember all this, because see, if you can prove in exam, that is also okay, but it's better to have some practice. Okay, so you don't have to remember anything. Okay, so what I did, I used to practice a lot. So in because I am not good with remembering anything, so I used to practice a lot, and that's why I like pasted on my brain. So that's why I don't have to remember anything. So you also do the same thing. You can, if you are like me, if you cannot remember stuff, so you can just practice. So practice will give you this edge. Okay, so now let's see some more topics. Okay, so then we will move on to gate questions. So now let's see, there is a theorem here. So let me read it out, and then I will try to make it easier. Okay, so theorem, this is easy, nothing to worry. Okay, so the poset dn, so dn is a relation, and this is the divisor, is sorry, dn is set, and this is relation. Okay, so I hope this is we have done all this, okay, a lot of times. So is a Boolean algebra. So Boolean algebra means in previous videos we have already seen that if the lattice is both distributive and complemented, then it is Boolean algebra. Okay, so distributive means it holds the distributive properties, and complemented means it at least has one complement, each element has one complement. Okay, so we have already done this in details in previous videos, so I am not going in details in here. So it's just because it will make the video longer, and it may feel tiring. Okay, so now let's see. If and only if, this is if and only if. Okay, so n is a square free number. So square free number, I'll come here. So square free number means if you find, let's from here jump into here. Okay, so let me write it like star here. So here, if you find out dn, and dn is containing all the numbers and none of them is a perfect square, then such number is called square free number. So let's say this d 110. So these are all the divisors of these numbers: 1, 2, 5, 10, 11, 22, 55, 110. So you can easily find out that no number in this, let me check if this is visible or not. Yes, it's visible. So actually I am not good with this making videos and all, so all I can do is teach. I hope I can make the videos, like from my side I am trying best to deliver the content good. So that's it. Video editing and all, I am very bad. So if you have seen, I never even create a thumbnail, so that's it. I am not good with all this. So anyways, so these are the numbers here. So this, you can see none of this number is a perfect square. Okay, so here this this holds. So this is the square free number. If dn is this containing all the numbers and none of them is a perfect square, then this d, let's say d 110 is called a square free number. So same thing here, we are using this square free number. The poset is a Boolean algebra if n is a square free number. So if, let's say, if the poset dn slash is a Boolean algebra, then the complement of x is n by x for all x belongs to dn. Okay, so this is just a theorem now we will do questions on this. So this is, I have just taken an example. So this is a square free number if it doesn't contain a perfect square. Okay, so this is also a Boolean, and it is using in the poset is a Boolean algebra if n is a square free number. So if here n here is a square free number, then you can say then this is poset is a Boolean algebra if and only if. Okay, so if and only if, double F means if and only if. So we are at the end of the concepts. If I find anything, I'll obviously add to the videos. So let me move on to questions now, because practicing questions is very important. Okay, so bye and see you in next video in questions.